Right, in this video I'm just going to practice writing a few full chemical equations. I'm going to start by just writing full equations, and then I'm going to go back and turn them into ionic equations. I'm going to assume that you can write ionic formula. If you can't, there's another video for that. I'm also going to assume that you can balance. The first one here, I've got hydrochloric acid. You need to know this off by heart. The formula is HCl. Then I've got sodium hydroxide. Sodium is in group 1, it's got a +1 charge. You need to know the hydroxide ion has a -1 charge. +1 -1 cancels out, NaOH. On the other side I've got sodium chloride. Again, sodium's in group 1 with a +1 charge, chlorine's in group 7, -1. The charges cancel. I just put the ion or the atoms together, and water is going to be H2O. My final equation should not have any charges. It's fine to use them for working out. They should not be in your answer. If I check, I'm going to see that this is already balanced. 2 hydrogens on each side, 1 sodium and 1 chlorine and 1 oxygen, so I can move on. The next one I've got is sulfuric acid and copper oxide. Sulfuric acid, you need to know, is H2SO4. Copper oxide, copper does have a +2 charge. You do need to know that. You won't find that on the periodic table. +2 -2 cancel out, you get CuO. On the other side, copper is again +2. The sulfate ion, you need to know off by heart, is -2. +2 -2, they cancel out, CuSO4. Water is H2O. To balance, I'm going to look at the sulfates, going to consider that as one thing. There's 1 sulfate on each side, there's 1 copper on each side, 2 hydrogens, 1 oxygen. It's already balanced. The next one I've got nitric acid and calcium carbonate. Nitric acid, I need to know, is HNO3. Calcium is Ca+2, it's in group 2. The carbonate ion, you need to know, CO3 -2. The charges cancel, CaCO3. On the other side, I've got calcium nitrate. Calcium, group 2 with a +2 charge. Nitrate, I need to know, is NO3 -1. These charges are not cancelling. So what I'm going to need to do is drop and swap. The 1 from the charge comes down next to the calcium. Notice I didn't move the 3, it's from the charge. So that's the 1 that's moving down. The nitrate is going to come next. I cannot change the formula of it, NO3. And then the 2 from the charge of calcium is going to come down here. Now if I just wrote a 2 there, I would suddenly have 32 oxygens, which is obviously incorrect. So what I do is I use a bracket to show that I've got 2 nitrates. So notice the NO3 has not changed. The actual formula of the atoms, that has not changed. All that has happened is the 1 that was next to the nitrate is now next to the calcium. The 2 from the charge of the calcium is down next to the nitrate. So it's just the numbers of the charges that are crossing. Everything else stays the same. Water is going to be H2O. Carbon dioxide is going to be CO2. To balance this, 2 nitrates on the right, I want 2 nitrates on the left, so I need a big 2. I've got 2 hydrogens then on the left and 2 on the right. I've got 1 calcium, 1 calcium, 1 carbon, 1 carbon, and I've got 3 oxygens there. 1 and 2 is 3 oxygens there, so that is also balanced. The next one, sulfuric acid and ammonia. Sulfuric acid, I need to know, is H2SO4. Ammonia, you also need to know, NH3. You've seen that in the Haber process. Ammonium sulfate. You need to know the ammonium ion is NH4+, the sulfate ion SO4 2-. Those charges do not cancel. I write down the formulas, NH4, SO4, and then I cross over the charges. The 2 from the charge of the sulfate is now going to be down here next to the ammonium. Again, I'm going to use a bracket. The 1 from the ammonium would be down here, but I don't need to include it because it's just a 1. Notice in all of the neutralization reactions, I was forming salt and water, but when ammonia is my base, I'm only forming a salt, no water. The last equation here is for triple students only. Combined students don't need to know this one. Ethanoic acid, draw it out, okay? You don't need to write it as a formula. It's Eth, so you've got 2 carbons, and it's an acid, so you must have a double bond O, a single bond OH. So that's your ethanoic acid. Sodium hydroxide is NaOH. Because it's an acid, it loses H+, and specifically, you're going to lose the hydrogen from the oxygen, and that hydrogen is going to be replaced by an Na. That hydrogen that you kick off is then going to pair up with the OH from the NaOH, and you're going to form H2O. The next set of equations are metal and an acid, but it's a similar process to writing the equations. I've got hydrochloric acid is going to be HCl. Magnesium by itself as an element is just Mg. Magnesium chloride, I need to work it out using charges. Magnesium's in group 2, chlorine's in group 7. I drop and swap the charges, I get MgCl2. Hydrogen's an element, it's diatomic, I get H2. To balance 2 hydrogens on the right, I need 2 on the left. That gives me 2 chlorines, 1 magnesium and 1 magnesium. Again, notice I'm using my charges to work things out, but I don't have charges in my full equation. Sulfuric acid next. Again, I need to know this off by heart. H2SO4. Copper, I need to know is Cu. On the other side, copper sulfate. Copper, we said, was +2. Sulfate is -2. That gives you CuSO4. And then hydrogen, again, a diatomic element, is H2. 2 H's on each side, 1 sulfate, 1 copper. It's already balanced. The last one, again, this is for triple students. Oh, sorry. This is for triple students only. Methanoic acid. It's got 1 carbon. It's got a carboxylic acid group. Carbon has to have 4 bonds, so on the other side of that carbon I must just have 1 H. That's methanoic acid. I'm reacting that with lithium plus Li. I'm forming lithium methanoate, so just as before, the acid is going to lose the hydrogen from the oxygen. It's going to be replaced by the group 1 metal, and you're going to form H2. 2 hydrogens on the right. To have those 2 hydrogens on the, so in total I've got 2 hydrogens there on the left, and now I've got 3 on the right. So to balance out those hydrogens, I'm going to need a big 2 there. That means I'm going to need a big 2 there, and then subsequently a big 2 there. As well as being asked to write full equations, which is what I've just done, you can be asked to turn these into ionic equations, which is what I'm quickly going to do now. And in order to write ionic equations, you're going to need state symbols, which should be provided in the question. Acids are always aqueous. Sodium hydroxide is an alkali, it's also aqueous. You should be told that sodium chloride is aqueous, and then water is liquid, it is L. And your rule is, if it is an acid, it will split into ions. If it is ionic and it's aqueous, it will split into ions. So if I go through this equation, this is an acid, it will split into ions. The ions I get are H plus and Cl minus. So notice when I split this into ions, I now do show the charge. I didn't show any charges writing a full equation, but writing an ionic equation, I need to show the charges on the ions. So I took HCl, I split it into 2 ions. To do that, I just put a plus between the H and the Cl, and I showed the charges that were on those ions. I'm going to do the same with NaOH. You have to remember that OH is itself 1 ion. So I'm not splitting the Na, the O and the H. I'm just splitting the Na from the OH. That one's +1, it's in group 1. That one's -1. On the other side, NaCl, what ions does that contain? It contains a sodium ion, Na+, and a Cl- ion. H2O is liquid. I don't split it up when it's liquid. So you're only splitting it if it's ionic and aqueous, or if it's an acid. Anything that is exactly the same on both sides is going to cancel out. So my Na+ is going to cancel with my Na+, my Cl- will cancel with my Cl-, and I'm left with H+ plus OH- goes to H2O, and that is your ionic equation. If I come down here to the next one, again, you'll have to be given state symbols. Sulfuric acid is an acid, so it will be aqueous. Copper oxide is solid, you'll be told that. Copper sulfate is aqueous, water is liquid. Sulfuric acid I need to split into ions. Again, you need to recognize that sulfate is itself one thing. SO4 2- is the sulfate ion. You're not going to separate those sulfurs and oxygens, but you are going to separate the sulfate from the hydrogen. Now, a common mistake here is we know hydrogen is H+, and what students will often do is they'll write a 2, just like it is in sulfuric acid. That small 2 says that 2 hydrogen ions are covalently bonded together, which is impossible. They're both positive, therefore they'll repel each other. Also, they have no electrons, so cannot form a covalent bond. There are 2 hydrogen ions, but instead of writing a little 2 that suggests they're bonded together, I put a big 2 out in front, 2 separate hydrogen ions and 1 sulfate ion. So when I break this up into ions, this is what I am left with. When I get on to the next bit, CuO, it is ionic, a metal and a non-metal. It is not aqueous, so it does not split, and that means I write it exactly the same as before. CuSO4 is aqueous and it's ionic, so it will split. You're going to get a copper ion with a +2 charge and a sulfate ion with a -2 charge. Water, as a liquid, will not split, H2O. Whatever is the same, I cancel out. What I'm left with is my ionic equation. The next one, again, my acid is going to be aqueous, so that is going to split, okay? If you have a look here, I've got H+, you'll always get H+ from your acid, and I've got NO3-, they're the 2 ions. You've got a big 2 this time in front of nitric acid. That means that that 2 affects the H's, but that 2 also affects the NO3. The fact that it's in front means it's affecting H and NO3. So I've got 2H+, 2 NO3-. Calcium carbonate is solid. Because it is solid, and you will be told that, it is not going to split and it stays intact. Calcium nitrate is aqueous. It's got a calcium ion with a 2+ charge, and it's got the nitrate ion, NO3-. That 2, because it's in brackets after the nitrate, only affects the nitrate. So I'm putting a big 2 in front of the nitrate. I'm not putting it in front of the calcium. H2O is a liquid. It does not split. CO2, a covalent gas. It does not split. The only ones that split are acids and ionic if they're aqueous. Whatever's the same at both sides will cancel. 2NO3-, 2NO3-. Everything else will remain. Something should always cancel, and if it doesn't, you've likely done something wrong. So if you hadn't put the 2 in front of the NO3, but you had over here, that's your clue to go back and check it, so that something is definitely cancelling. The next one, I mean, unlikely you'd be asked to do this one, but I'll do it for the sake of it. Sulfuric acid is going to give you 2 H+ ions. So your little 2 there only refers to the hydrogen, 2 H+ ions, and you've got your SO4 2-. Ammonia in this case would be dissolved in water, but it's not ionic, so it's not going to split into ions, so it's just going to be NH3. And then on this side you've got 2 ammonium ions, so it's going to be a 2 in front of the NH4+, and you've got your sulfate ion SO4 2. Here my SO4 2 cancelled, and then this is what I'm left with as my ionic equation. You won't be asked for ionic equations for your organic chemistry ones. I mean, it's very similar if we were, but I'm not going to do it now. Redox, you can be asked for an ionic equation for this one, so I'll do this one out. Hydrochloric acid, you're going to get a H+ ion. You're going to get a Cl- ion. Remember, it's an acid, so it will split. The big 2 in front means you've got 2 hydrogen ions and 2 chloride ions. Magnesium is a metal. It will not split into ions. Over here, MgCl2 is ionic and it will be aqueous. You're going to get an Mg2+ ion and you're going to have 2 Cl- ions. H2 is a gas. It will not split into ions. That's cancelling this time. My spectator ions, my 2 Cl-. The next one, I have got sulfuric acid. Again, if it's an acid, it will split into ions. I'm going to have 2 H+ and SO4 2-. Copper is a metal. If it's a metal, it's not going to split. It needs to be ionic and aqueous, or an acid. Copper sulfate is ionic and it will be aqueous. You're going to get Cu2+, you're going to get SO4 2-. Hydrogen is a gas. It will not split. This will cancel, this will cancel, and that is what you're going to be left with. Again, on the organic one, you wouldn't be asked to draw it out. But if you did, it would be the same. You'd draw this with a negative charge. You'd have your hydrogen with a positive charge. On this side, this would separate as well. You'd have this with a negative charge, the lithium with the positive charge, and your 2 organic ions would end up just cancelling out. Okay, so that's just a quick flick through writing full equations and writing ionic equations. The next video goes through some exam questions of the same type.